tell you.
Come up with another situation here. We're getting stuff that's migrating in from California that has no heat strips. Absolutely none. Won't sell them there.
Really? Wasn't aware.
Oh.
If you have no heat, then you don't have that tool that's necessary to calculate the CFM. And now you're getting into some pretty sophisticated...
Here, I know. I've got a friend who brought them up when I'm over.
Well, you'll find some in residential applications in Tucson as well. I mean, you know, a little remodel that maybe only took a little bit over a ton in capacity, but it was a garage, and the smallest thing somebody could get was a 2-ton. You know, there's twice the capacity you need, so obviously there's not a need for the additional supplemental heat.
Could you give me the formula for KW to BTUs again?
KW to BTUs?
Yeah, how many BTUs?
3.41 BTUs per watt. So if you got a 10 kW, that's 10,000 watts times 3.41, gives you 34,100 BTUs. You know, that's fortunately this is the only formula I'm going to give you, so you don't have to commit a bunch to memory. White chalk won't work on that board.
White chalk on a whiteboard doesn't.
Okay.
Magic mark question.
Will the thermostat automatically, if there's no indication on the thermostat of additional heat strips, does that necessarily mean that the heat pump does not contain one?
The thermostat really doesn't tell you whether there's heat there or not. You could have a thermostat that has an auxiliary heat position or emergency heat position. Some people call it supplemental heat, depends on the manufacturer. And it could have lights on it. The light lighting up doesn't tell you anything except, you know, the thermostat is demanding it if it is there. It may or may not be there. You physically have to open up the equipment and find the heater to know that it's there. It's the only way. You've got to actually physically inspect to find it.
When you turn it to emergency heat and the heat pump shuts down, then it probably doesn't have any?
Well, when you turn it to emergency heat, the heat pump should shut down. The only time you go to emergency heat...
But then your blower and everything shuts off. That's telling you that there's no emergency heat at all up there? No heat strip?
Well, that would probably be a good indication, but normally when you put it to emergency heat, your blower would run. I mean, that's generally a function of the thermostat. So the thermostat is going to cause the air handler to run. Now, if there's no strip there, of course, you won't get any heat. The other thing is you may have the heater there, but when the thing was installed, it wasn't wired properly. So if you've got a strip and it doesn't come on, you've got a problem with the control wiring. It should come on when you put it to the emergency heat position. Otherwise, it's a useless function of the switch. And perhaps we can look at the demonstrator in a little bit and show you how that would operate.
Up north, where I live, we see heat pumps that have several strips, some as many as 4 to 5 heat strips in those things. Do they all cycle at different times, or do they, like an electric furnace, or they can all come on at once? Really, you know, for us to know is if 3 of them are working and 2 are not, based on using a thermometer or an amp probe rather than opening it up.
It could be several different ways. They could, as they showed you in the video, you can actually put ambient temperature thermometers out there or switches to stage them on based on outside temperature. There's no point in bringing up 20 kW if you don't only need but 10 to work it. It's pretty inefficient to run that way. So you could put it on ambient thermostats and actually cycle it that way. Or it may be all connected to your thermostat.
We wouldn't know doing a visual inspection.
You wouldn't know.
All 5 of the coils were coming on.
No, about all you could do would be to turn the temperature all the way up. And if you know you got 20 kW, then you're going to look for the 20 kW to come on. If it doesn't, then you need to go to the outdoor unit and look for ambient controls that may be locking some of it out based on outdoor temperature. Okay, okay. If you take, say, a system and we've determined the heat output of the strip heater, and we divide it by the temperature rise, you come up with a CFM. If we took a simple number, say we're dealing with 10 kW, which is, again, 34,100 BTUs, and say you got a 20-degree temperature rise, divide that by 20, you're going to come out with 1,700 some odd CFM. If you've got a 5-ton system you're dealing with, you're obviously low on airflow. If you've got a 4-ton system, you're a little bit over. But that's, you know, okay, better to be a little bit over. You're nowhere close on the 5-ton, and you're close on the 4, because you're looking for about 1,600 CFM, 400 CFM per ton. If you're way under on airflow, then you're going to have problems with possibly tripping out on head pressure, on heat pump operation, and things of that nature. Also, you're not going to get your full performance or efficiency.
Would checking the CFM of a unit put us in a status of giving technical information?
I wouldn't say so. I mean, it's in order for you to make any sort of judgment of whether the thing is working properly or not, air is critical, and you really need to know. And it's something that's overlooked by, you know, service technicians that do this for a living on a routine basis. You know, it's so easy to go out there and throw a thermometer in there and say, yep, I've got my temperature drop, it must be working right. Not necessarily so, especially on older equipment, where, you know, maintenance hasn't been taken care of the way it should have been over the years, and you've got a, you know, I'm sure you've seen it, an evaporator coil that actually looks like a doormat. It's a wonder there's any air at all that goes through it. Now, when you're dealing with a heat pump in the heating mode, you've restricted the airflow. You know, it's going to look like it's got a wonderful temperature rise, and it will have. But it's awfully tough on the equipment because it's creating a big differential between suction and discharge pressure, which the difference between the two is your compression ratio, and it really makes the unit work very hard and inefficient, and it's going to cause excess wear on the system and high utility bills. Yes, sir.
I have a question. Supplier seems to vary greatly on these things. You know, you get good split temps on the same machine, house to house, and the supply temperature, which I just been taken just out of curiosity. Sometimes it'll be around 60, sometimes it'll be 65. In identical houses, there's one particular builder that's got about 10 identical units. The other thing that they mentioned in there that really caused me some concern is the evaporative A coils being constructed for a heat pump only. Because I know here in town, there's a particular installer for a large track builder that is converting ACs by putting 4-way valves in them and calling them heat pumps. No names mentioned, but I did not know that until I saw that on that film. What's the ramifications of that? And other than the obvious, where you can see where they soldered in a 4-way valve, how does a guy keep his butt covered on that one?
That's a good question. I've never heard of such a thing being done. There is a difference between a heat pump coil and an air conditioning coil. Now, depending on the manufacturer, some make a universal coil, depending on the application. Carrier, for example, uses a couple of different metering devices. Depending on the efficiency of their equipment, you might be able to use what they call an accurator. In the one, it eliminates the check valve because in the one direction it slides up and restricts, and if the refrigerant goes the other way, it slides and bypasses that restriction. Now, that coil can also be used for a straight cooling application. If you need an expansion valve to get the higher SEERs out of equipment, then they either put on a special expansion valve which will meter in one direction and actually bypass in the other. Or, as the movie indicated, you need an expansion valve to meter in the one direction and then a check valve to allow the refrigerant to bypass the valve in the other. They have specific coils, some manufacturers, that have to go with specific condensing units in order to get the full efficiency out of the system. It's a matched system. If you put in anything other than that, the manufacturer isn't going to guarantee that you're getting your capacity or efficiency.
Bob, if I may, home inspectors aren't very good at waiting till the end to ask questions, as you've probably been able to figure that out. And I had a couple of quick. How long is your presentation going to be?
Well, he's covered most of it, so it shouldn't be long.
Okay. Can we take a 5-minute break and no longer, and then we'll continue. I want to make sure we have enough time to
Sure.
do the presentation. Okay, 5 minutes.
Okay. Sure.
Hi, Mike Williams. I talked to you a couple times on the phone.
Yeah, how you doing?
Sure. Short attention span. We need to break him out here for 5 minutes.
You ever got the one? That deal really helped me.
Yeah, oh, you especially.
What do you mean, me especially? What do you mean?
There's no heat strips, that's one deal.
That's the formula.
I have a question for you.
Yes.
Is it 3.413 BTU per 1 kilowatt, or is it 3413 per kilowatt? Isn't it 3.413 per watt?
Per watt. Yeah, did I say kilowatt?
Yeah. I kind of wondered about that, but that's okay because...
You've just been spouting formulas up there like...
Okay, as we were saying before the break, CFM, and we've got it up on the board now so you can see the formula, equals the BTUs. BTUs, again, when you're dealing with a strip heater, it's an easy conversion, kW, or 1 watt, and I think I may have said kilowatt before, 1 watt is equal to 3.41. 3.41 BTUs per watt. So if you had a 10 kW heater, it would be 34,100 BTUs of heat that you're generating with that strip. You're also, if your motor's in the airstream, you're putting a little bit additional heat in there. But you know, for your purposes, it'll really give you a pretty accurate number. Again, on the divisor, we can drop in Tucson but if you're at a different altitude, you might want to consider this a factor, or get an altitude correction factor for your particular altitude. You'd have to go to some sort of a manual to pick this information up. But in Tucson, it works out very nicely because normally the factor we're dealing with is 1.08. But when we correct for our altitude, you can just disregard that because it comes so close to 1, it doesn't matter for our purposes. Okay, were there any further questions on this formula?
So no way to do that without heat strips, right? Or,
No, if you don't have heat strips and you suspect you're low on air, it's going to take some pretty sophisticated air detection equipment, and probably your best case is to say, you know, I don't know, it doesn't look like it's working right to me, or it does look like it's working, and get a licensed contractor out there that has the equipment necessary to make those sort of checks. You can also take this formula and turn it around. Say now you know, you've had your strip heater, you figured out the thing is moving, say, approximately 1600 CFM, okay? And the outside temperature is 50 degrees. Turn the heat pump back on and get a temperature rise off the heat pump. Make sure that the strip is not operating at this time, that it's solely the heat pump, and get a temperature rise. If you got a temperature rise, and you know what the CFM is, if you multiply the temperature rise times the CFM, it'll give you the BTU output of the heat pump. So you're just switching the formula around. And if you've got a 4-ton machine, and one that's rated at 4-ton, 48,000 BTUs at the standard rating of 47, and it's 50 degrees outside, if you measured 1,600 BTU, or 1,600 CFM, and say you got a temperature rise from the heat pump of 30 degrees, then you would have 48,000 BTUs, which is what you should expect that heat pump to produce at approximately 47 or 50 degrees outdoor temperature. It would let you know that the heat pump is actually